The purpose of this particular video is to help you write electron configurations in the two main possible ways. The first involves showing the sublevels in order from lowest to highest and how many electrons are present in each of them based on what material you're trying to represent. The second is using the Bohr notation, which is really only showing principal energy levels. And that'll be the second portion of this video because I personally find it easier to write them once you've spelled out the different sublevels and the presence of the electrons in them. So the first thing to recognize is the order of the sublevels from lowest to highest, because if you only have 15 electrons, they're not all going to fit into the first possible sublevel. So you're going to have the right sequencing to place all 15 of those electrons so that they're in the lowest available ones without really skipping ahead. The periodic table is set up in a really ingenious way. It actually goes in order from 1s, and so as you can work your way through 1s, it fills up with 2 electrons. That's something you learned in the video that explained the difference between principal energy levels, sublevels, and orbitals. Then you go on to the second principal energy level into sublevel 2s, which has 2 electrons. So you'll notice how that's 2 columns wide on the periodic table. After 2s comes 2p. P had 3 orbitals in it, which meant it could max out at 6 electrons. So this this section is 6 elements wide. After 2p, the next energy level is 3s. Then the next sublevel is 3p. And then, unfortunately, you would think it's 3d, but there starts to be an overlap between the different principal energy levels. And in reality, sublevel 4s will have less energy than sublevel 3d, and therefore it will come before 3d. And as you continue through the periodic table, you start to see more and more of this overlap, because starting right about here, between 6s and 5d, you actually have 4f. You'll notice that with the atomic numbers on your periodic table. And between the 7s and the 6d level, you have 5f. So there starts to be more and more overlap. You certainly can use the periodic table as a reference to figure out which sublevels come next, or you can use the trick that I'm going to show you on the next page. And the order in which you set up your sublevels from lowest to highest involves setting up a little chart first. And you'll set up all the s's in one column. So you start with 1s at the top and work your way down to 7s. In the next column, you start the p's, which begin at principal energy level 2. So there's a 2p down through a 7p. Sublevels D begin on the third principal energy level, so 3d down to 7d. And then the F sublevels begin with principal energy level 4, so you start that column at 4f and work your way down. Now if you go up top and you draw diagonal lines, the sequence in which your pen passes through the sublevels as you draw these parallel diagonals is the order in which you fill your sublevels. So first, my cursor is going to pass through 1s, and I come back around. It comes down through 2s. If I come back around, it'll pass through 2p and then 3s. If I come back around, I go through 3p, then 4s, and again passing back around through 3d, 4p, and 5s. And it would continue basically as far into this pattern as you need to in order to place all of your electrons. So here's the process. The first question you need to ask yourself is how many electrons does the atom or the ion have? If it's a neutral atom, this should match the number of protons or the atomic number. If it is an ion, you'll need to adjust that number by either adding or removing electrons. Remember, negative ions have extra electrons, and positive ions are missing some electrons. So first, figure out the number of electrons you're going to be placing. Second, you want to start with the lowest or the first sublevel and work your way up until you've placed all of your electrons. This will ensure that you're in your ground state where all the electrons are in the lowest possible levels. This is based on the principle called the Aufbau principle. When you build a house, you start with the basement, the foundation, and you work your way up. The same thing happens with the electrons. And then just as a reminder, no more than 2 electrons are allowed in an orbital. So those maximum values for S, P, D, and F will be 2, 6, 10, and 14 respectively. If you overfill them, you have violated some of the principles here. That's not going to work. So you have to hit the right maximum before you move on. So let's look at a couple of examples, and I'm doing this with, I guess I'm going to type it. It's probably our best bet, as opposed to trying to draw it with a pen, although I think with the recorder the typing isn't happening so easily. So suppose we were going to do hydrogen. Okay, sorry about the sloppy handwriting here. Hydrogen has just one electron. So the way we're going to write this is sublevel 1s, and you always have to include the number with the letter. And then as a little exponent, even though it's not really representing anything exponential, I'm putting a 1. This is indicating that there is one electron inside sublevel 1s, which is in the first principal energy level. If I look at something like carbon, which has 6 electrons, I can't fit all 6 of them into 1s. So I'm going to start with 1s and work my way up. So first is 1s, which can only hold 2 electrons. So that's 2 of my 6 electrons are in 1s. My next sublevel is 2s, and that 2 is not a multiplier. It's simply telling me that the second s orbital, or a second s sublevel, is in my second principal energy level as opposed to my first. And this one also can hold 2 electrons. So if I look at my exponents, which really aren't squaring anything, I have a total of 4 electrons being used. And now I have 2 more to go. So the next sublevel is 2p, which even though it can hold 6, I only need 2 more to find a spot. So it's 1s2, 2s2, 2p2. Please don't call them squared or cubed if you have a 3 anywhere, because that will really start to cause some confusion when you're tallying up how many you have. And then the last one that I want to draw with you is perhaps aluminum. Aluminum has 13 electrons. And so again, we start at the beginning, 1s2. And now I have 11 to go. So next comes 2s2. That leaves me 9 more. Then it's 2p, and my p's go up to 6 electrons because there's 3 orbitals in there, and they can each hold up to 2. So 2p6, that's 10 of my 13. Next is 3s, and 3s can hold 2. So now I'm at 12, and then 3p is next. And there's only 1 electron left, so I put a 3p1. And this is how you generally write out the long versions of the configurations. There is a shorter version, and I'm going to show you that on the next slide. Very often it's called the Bohr notation, and it basically consolidates what you have in terms of sublevels and lumps them into principal energy levels. So if you look at this particularly colorful one, I've written everything from principal energy level 1 in red, and that's because there's a 1 in front of it. There are 2 electrons that are red. That's my first number in my Bohr configuration. Anything in principal energy level 2, with the 2's in front, is written as green. There are 8 of them there. That's my second number in the Bohr notation. Anything with the blue, you notice they start with a 3. They're my third principal energy level, and so they add up to 18 in this case. And my fourth, in this case I have 4s and 4p, there's 4 of them. The maximum in my fourth level with s, p, d, and f all filled is 32, but I only have 4 in this particular case. If you were to draw Bohr diagrams, what you would draw is a nucleus, and you would list the protons and neutrons in it, and then you would draw rings outside of it that sort of look like a picture of a solar system. And on the first ring there would be 2 dots representing 2 electrons, 8 dots on the next ring representing the second shell, or second principal energy level, 18 on the third, and 4 on the fourth. I personally am not really in the mood to count 70 dots, and I know it gets confusing or you lose track when you're drawing them. So if you do this for me, I would greatly appreciate you just writing a number on the ring so that I know I've counted it properly and that you've drawn it right. So I would just label them with a 2, an 8, an 18, and a 4.